So this video is an intro to binomial expansion. So we're being asked to expand this binomial. So if we were taking basic algebra, we would go x plus y, 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 and we get a cup of coffee because it's going to take a while to multiply this. But there's a much quicker way if you look at the pattern through all of this. So if we expand these binomials, you can see that we end up with this nice pattern here. This is actually called Pascal's triangle, the coefficients that is. So we start with a 1 triangle, and there's 1's on the outside, and then if you add, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 1 is 3. You can see that by adding the coefficients, you get the coefficients of the next binomial expansion. See? So they build off of each other. You can also look at the exponents. If we have an x here and a square, the first one's x squared, and then they descend. So there's a lot of patterns going in here. And then the y at the very end, so look, y to the 5th, it descends. So we're going to take this and use these patterns to create this. But you don't want to memorize this stuff. You want to have a nice, clean pattern. And Pascal's triangle is great, but using binomial coefficients, this right here are combinations to create our binomial coefficients is a lot quicker. So if you look at this, if we do, let's just look at the degree 2. So if I do 2, choose 0, I get 1. A 2, choose 1, I get 2. 2, choose 2, I get 1. So by doing these combinations, they create our binomial coefficients. So a degree 3, we would go 3, choose 0, 3, choose 1, 3, choose 2, 3, choose 3, and so on. But there is a quicker way. So what we're going to do, instead of having to input each of these individually every single time, we use the y equals function, and we plug that combination formula into the y equals, leaving the x here. So this way it'll be 5. And then our calculator will plug in for x, like this. It'll plug in 0, and then 1, and then 2, and then 3, and then 4, and then 5, and spit out our coefficients. So if we want to create that 2 thing again that we just did, the coefficients for the x squared, you would hit y equals, and then math, scroll over to our probability and number 3, and then now we put in our degree, it's 2, and then we place an x here. And you want to hit second and window, that'll give us our table. Set. Make sure it says 0 and 1. And then you go to table, and there they are, 1, 2, 1. So you can do this for any coefficient now. You can just plug in here. So if I said degree 4, I go to my table, and look, there's the coefficients for 4, 1, 4, 6, 4, 1. If I even wanted it for 10, scroll over, put in 10. Go to my table, there's the coefficients for a degree 10 binomial. That's massive, right? So, okay, for our degree 10 expansion of our binomial. Power of 10. All right, so let's try these now. So our first one we're going to expand, this is what we're looking for, is x plus y to the 5th, and we're not going to multiply this out. So it's been plugged into the calculator, and it gave us 1, 5, 10, 5, 1. So that is our coefficients. 1, 5, 10, 10, 5, 1. And there should always be one extra number past our degree. So if you're doing with a degree 5, you're going to get 6 numbers. A degree 4, you get 5 terms. Degree 3, you get 4 terms, and so on. Okay, so we have our first set of coefficients, and now we do the variables. So we bring these coefficients down, 1, 5, 10, 10, 5, 1. And we take our first term, which we know would be x to the 5th. We place it here. And then all you do is descend it. And there you go. And then the last term we know would be y to the 5th. And then you descend it. And there you have it. That is our answer. So it's x to the 5th plus 5x to the 4th y plus 10x cubed y squared plus 10x squared y cubed plus 5x y to the 4th plus y to the 5th. And there you go. Fully expanded x plus y to the 5th.